Did you know that every second your body burns 8 billion molecules of glucose? That's more grains of sand than all the beaches on Earth in just 10 minutes. But here's the question. If glucose is so important and humans can't photosynthesize like plants, where does our glucose actually come from? Today, we're breaking down the fascinating journey of glucose from food to bloodstream and meeting the entire carbohydrate family along the way. Summary: the glucose legacy. Hundreds of millions of years ago, plants invented a system to create glucose using sunlight. When humans arrived much later, we didn't invent a new fuel system. We simply used the same one. Every cell in your body depends on glucose. Heart cells use it to beat. Brain cells use it to think. Eye cells use it to see. Red blood cells use it to transport oxygen. Glucose is your body's preferred energy source, but unlike plants, we can't make it from sunlight, so we eat it. Starch, glucose in chains. Let's start with bread. Bread contains flour. Flour comes from wheat. Wheat is packed with starch, and starch is simply long chains of glucose molecules linked together. When you chew bread for a long time, it starts tasting sweet. Why? Because an enzyme called alpha amylase begins breaking starch into glucose right in your mouth. Most of this breakdown happens quietly in your gut, where enzymes snap those glucose chains apart and release free glucose into your bloodstream. Fruit, already sweet fruit, is different. It already contains glucose, fructose, even sweeter, sucrose, half glucose, half fructose. Glucose from fruit is ready to use immediately. Sucrose is quickly split. Fructose is partially converted into glucose, but your body doesn't actually need fructose the way it needs glucose. And today, we consume far more fructose than our ancestors ever did. Half fiber, the special one. Now let's talk about fiber. Unlike starch or sugar, there is no enzyme that can break fiber down into glucose. So fiber doesn't raise blood sugar, doesn't enter the bloodstream, doesn't provide energy. But that's a good thing. Fiber supports digestion, keeps bowel movements healthy, feeds your gut microbiome, slows glucose absorption. Fiber passes through us and helps us in the process. One parent, 4 siblings. Think of it like a family. The parent, glucose. The 4 siblings, starch, fiber, fructose, sucrose. Together, they're called carbohydrates, or carbs. Scientifically, carbohydrates equal starch, fiber, sugars. But in everyday language, when people say carbs, they usually mean starch and sugar, not fiber. That's why you might hear, broccoli has few carbs but lots of fiber. Scientifically, that's not precise because fiber is technically a carbohydrate. What if we eat no carbs? Now, here's something surprising. Carbohydrates are not biologically essential. If you don't eat glucose, your body can make it. Your liver performs a process called gluconeogenesis, creating glucose from fat or protein. And when glucose is scarce, your body can switch to burning fat for fuel, a state called metabolic flexibility. This is what happens during keto diets, Atkins diet, nutritional ketosis. The only cells that always require glucose? Red blood cells. So technically, we don't need to eat carbs to survive. But carbs are a fast energy source, historically part of human diets, and deeply woven into our food culture. Core message: glucose is life's fuel. Plants invented it. Humans depend on it. Food delivers it. Starch becomes glucose. Fruit delivers glucose. Fiber supports the system without becoming glucose. And your body is flexible enough to survive, even when carbs disappear. But today's food environment looks very different from what nature designed, and that changes everything. Outrow. Now you understand how glucose enters your bloodstream, and why not all carbs are created equal. If this helped you see food differently, hit like, subscribe, and stay curious. Because when you understand how your body works, you take back control of your health. See you in the next chapter.